Welcome back to Physics 135A tutorial videos. So now we're going to practice our unit conversions with the technique covered in class where we successively multiply by the number 1, changing the units step by step. So the first task is to convert 1,000 centimeters cubed into meters cubed. So the number should shrink because a meters cubed is larger unit than centimeter cubed by a lot. So what we're going to do is write the original amount, and then we're going to multiply by 1 and 1 and 1 again. But what is the number 1 in this sense? Well, how many centimeters are there in a meter? We want to get rid of centimeters in favor of meters, so we say 10 to the second power centimeters. 1 meter divided by 100 centimeters, that's just the number 1. Those two things are equal. If you divide a meter by 100 centimeters, that's like saying a divided by a or x divided by x. That should be 1. And so we're going to replace these three instances of 1 with 1 over 100, 1 over 100 meters, and centimeters are on the top and bottom respectively. And so there are 1, 2, 3 centimeters in the denominator, and there are 3 powers of centimeters in the numerator, so they all cancel. There are 1, 2, 3 meters in the numerator, and so the final units will be in meters cubed. But now look what happens. We have 1,000 in the numerator, so there's 1,000, 10 to the third power, and then divided by 10 squared times 10 squared times 10 squared. And so that's 10 to the third power divided by 10 to the sixth power, or 10 to the minus 3, and the units are meters cubed. So it ended up being dividing by 1,000,000, or 100 cubed, and that changed the units from centimeters cubed to meters cubed. So that's 10 to the minus 3. Now we have a compound unit where instead of just all lengths, there's a length divided by a time, so that's a speed, and it's a fraction of 1 unit divided by another unit. So we're going to have to copy those this amount here and then change this fraction from meters per second to kilometers per hour. So we're going to want to eliminate meters in favor of kilometers. So I think we're going to want to put 1,000 meters is equal to 1 kilometer, right? So the 1,000 meters belongs in the denominator, so as to cancel the meters in the numerator. But then seconds is in the denominator now, so we want 3,600 seconds is 1 hour. Where did I get 3,600 seconds equals 1 hour? It's 60 times 60. So 60 seconds per minute, 60 minutes per hour. So 60 times 60 gives you 3,600 seconds per hour. So meters are in the top and bottom, they cancel. Seconds are also in the top and bottom, they cancel. And you have 30 times 3,600 divided by 1,000, so that's just 3.6. And then the units are kilometers per hour now. And so what is 30 times 3.6? That's like saying 36 times 3. 3 times 6 is 18. 3 times 3 is 9, 10. So 108. 108 kilometers per hour. If it was 30 times 4, that would be 120. If it was 30 times 3, that would be 90. So it's got to be somewhere between 30. It's got to be somewhere between 90 and 120. Yeah. So 30 meters per second is equal to 108 kilometers per hour. Finally, we've done this one in class. The conversion of a density in grams per centimeter cubed into kilograms per meter cubed. This is going to require actually 4 unit conversions. So 1 gram per centimeter cubed. Let's multiply by 1 and then 1 cubed. So uh, I'm going to do the length because I did centimeters to meters cubed up here, and I did the same thing 3 times. So I think it's more efficient. That's like saying, you know, something cubed is like doing the same thing 3 times. So what I want to do first is eliminate grams. So there are 1,000 grams in a kilogram. But then there are 10 to the second power at 100 centimeters in a meter. So the things I've written in parentheses again are 1, a kilogram divided by 1,000 grams. That's just 1, for example. But now notice that you have centimeters cubed in the bottom and centimeters cubed in the top, centimeters cubed, grams in the top, grams in the bottom. And so that's going to be equal to 1 times 10 squared cubed over 10 cubed, and then the units will be kilograms in the numerator per meter cubed, like that. And so that will be 10 squared, and then cubing that is 10 to the 6th divided by 10 to the third power kilograms per meter cubed. So 10 to the 6th divided by 10 to the 3 is actually 1,000. So if you have a substance that takes up a gram of mass within the volume of a centimeter cubed, if you grow that volume to a meter by a meter by a meter, then you'll have 1,000 kilograms. So the density of ice, almost a gram per centimeter cubed. It's really 917 kilograms per meter cubed. So this has been a practice session with unit conversions and successfully multiplying by 10 while treating the symbols of units like variables that can cancel each other.